So, good evening, everyone. On behalf of the InApp, I would like to extend a warm welcome to each and every one of you joining us today for this webinar. I am Samphullanath M, working with InApp for the past 10 years, currently playing the role of technical architect. It's an absolute pleasure to have you all here with us from different corners of the world. We understand that attending from different time zones and adjusting to various schedules can sometimes be a challenge. So we truly appreciate your effort that you have made to be here. Thank you once again for being with us today. And let's dive into today's session on driving business growth with conversational AI solutions. The session centers around a case study of Microsoft Azure's Cognitive Language Understanding. So this means the CLU. As business across industries seek new ways to enhance customer experiences, streamline operations, and stay ahead of the competition, conversational AI has emerged as a transformative tool. The AI focused on I don't need to talk much about the natural language processing. And the conversational AI has emerged as a transformative tool. Whereas the conversational AI mainly focuses on interaction between the computers and humans through the natural language, where it enables the machine to understand the natural language like what we talk to individuals. The AI-driven conversations are reshaping how companies engage with their customers, improving the efficiency and ultimately the drive growth. And here we will talk about the natural language processing as well as the conversational AI. The conversational AI basically relies on the natural language processing to understand and process the user queries that are faced in everyday conversational languages. So the main characteristics of the conversational language or the conversational AI or the conversational query is basically it doesn't need to have a strict syntax or the structure required. Users can simply ask questions to make requests in natural language, like they would in a conversation with another people. The system is designed to interpret and process these queries without needing a rigid format. Like we can talk, like we can say, book a flight to Eugene or book a flight to Oregon. So in this kinds of syntax or like what we talk to others, we can use the same structure or the syntax for making the queries. And here, we don't need to have a technical expertise. Like the user don't need to understand the complex queries or the language or syntax. We all know that the basic query structure that we all follow will be a structured query language. So we don't need to understand the basic underlying technology or the underlying query syntax or the structured language for the same. We can directly ask the system like, what's the weather like? Or any kind of complex questions in which the system is designed to handle. The common usages that we see conversational AI is basically what we see in conversational bots. Like in most of the applications, like nowadays, the common applications there will be a lot of chatting or the conversation or the AI bots are available for answering our queries. And the basic one of the other feature is the user friendly. Like we can ask the such as an enterprise chatbot. Suppose we have a query, we can ask the chatbot to answer ask the chatbot to make a query and to generate the outputs for the same. So the basic examples of a conversational query is basically what we like, show me all the laptops available in the store, or find a laptop under $500. So the system would process these questions using the natural language processing, and it understand the intent and provide relevant results, even though the phrasing is varied or even it is less structured. Like we can communicate to the machine with our natural language or the common language, what we are talking. And like what I mentioned earlier, we mainly focus on the Azure cognitive services for the languages. And Microsoft's standpoint in the natural language processing contains a various number of tools. And these tools, some of these tools have inbuilt or pre-built capabilities to manage or to implement the conversational AIs. And one of the tool is Extract PII, where this capability uses the named entity recognition to identify sensitive personal identifiable information in a text and categorize them into predefined classes such as persons, email, phone numbers, passport, bank account numbers. So we can identify each and every entity in the text that we are giving as an input to the system. And another one is extract key phrases. The key phrase extraction is an API that evaluates the structured text and asks and returns a list of key phrases. This capability is used for if you need a quickly identify main points from the text. Suppose like what we in an online system, we are talking about some kind of text. We are talking about a topic, and we need to identify the basic content about or the basic abstraction or the basic key phrases from that text. So all these informations can be processed from this extract key phrases tool. And find linked entities is a pre-built. It's also a pre-built capability that identify the entity found in the text by linking it to a knowledge base, such as if we are talking about laptops. So we can link those laptops to the knowledge base what we have. And the next is extract named entities. It's a pre-built capability uses the named entity recognition to identify the entities in the text and categorize them into predefined classes such as persons, location, event, product, and organization. Here we can name each and every entity based on our needs. And the custom named entity recognition is what we use. We can specify our own entities for the same. Like suppose if we are talking about locations, so we can specify location as an entity, and we can specify states in the US can be defined as an entity instance for the same. And another categorization of tools that is provided by the Azure Cognitive Services is the text classification. So basically, the text classification is used to analyze the text and its sentiments and its emotions. So the text and analyze sentiments and opinions is one of the tools that we used for identifying the sentence, the sentiments or the emotion in the sentence. So the text analytics API sentiment analysis feature provides a sentiment label such as negative. It gives us neutral or positive, and a confidence score on the sentence. It can be also used at the it can be also used by means of document level also. We can specify a document and read the content and see how it is going or whether it is a negative opinion or a positive opinion or whatever it may be. And the another one is detect language. So detect language is an Azure Analytics API that evaluates the text or the document or the text in the document and find its language. So we can identify whether it's whether the content of the document or the content of the text has been written in Japanese or in Chinese or whatever it may be. And the custom text classification, we can build our own AI models to classify the text into predefined custom classes. So we can label data, train and evaluate and improve the model and train and improve the model performance for deploying the model and making it available for the usage. And the next set of tool is the understand questions and conversational language. So the answer questions is a pre-built capability. It's also a pre-built capability that used to extract answer to the given question from a passage provided. The extract questions and answer from can be generated from your semi-structured content, including FAQs, manuals, or documents, or whatever it may be. And in case of custom question answering, we can define our own answers or our own answers based on a knowledge base to create a natural conversation layer. So by creating a custom QA project, we can iteratively add question, answer, word, PDF, and URL resources, and add new questions and answers on the fly. And the main topic the main topic here is the conversational language understanding, which we will be talking about. So as a quick, it's a project contains both labeled data as well as the models that are trained from that data. The labeled data consists of utterances that you can annotate and annotate with entity labels and categorize them into intents. And the final one is the orchestration workflow, where we can connect the CLU, question answering projects, and other applications into a complete workflow. We can iteratively label utterances, train it, evaluate, and also improve performance on the orchestration completely, and to make it more efficient and make it available for the consumption. And summarize information. This is also a pre-built summarization API that can produce a summary for a conversation or from a document. The conversation summarization can summarize upon aspects, and the document summarization has several types. And the final one is the language translation, where it's an ongoing process, ongoing project from the Microsoft Cognitive Services, where we can translate from one language into another one. So let's have a quick walkthrough on the tools that we use in the Azure Cognitive Services. So as you can see in the screen, so these are the technologies or the tools that we have discussed right now. And here is the PII. So you can use the languagecognitive.azure.com for trying it out. So here you can see that this is the personal identifier information, and this is the text that we are given here. And suppose if it's a legal document or it's an email review, and if we can run it, then we can generate the identifier information and the protected health information from that one. So here you can see that Mateo Gomez has been identified as the person, and here he's talking about his spouse, and it's identified as a person type. And also there are a couple of other entities that has been identified from that text. You can try it out all from the Language Studio itself. And now we'll be going to the Microsoft Azure Conversational Language Understanding. Conversational language understanding. It's actually basically a cloud-based service that enables the application to understand and interpret human language. This cloud-based service has been developed by Microsoft. And the previous generation of this tool was defined as LUIS. LUIS is nothing but language understanding. That was the first name. That was the first name of the tool which has been generated by the Microsoft. Later, it has been renamed to Conversational Language Understanding. And this service of the Microsoft that enables the application to understand and the process natural language. That is, you can build our own custom AI models to custom natural language understanding models to predict the overall intention of an incoming utterance and extract important information from it. We can literally iteratively label utterances, train, evaluate, and improve model performance before deploying the model and making it available for consumption. The common usages, like what we discussed, it will be basically end-to-end conversational bots, human assistant bots, command and control applications, and enterprise chatbots, and customer support applications. Talking about my Azure CLU process components, the main process of Azure, the main components of CLU is the entity, intent, and utterances. Entity, like what we discussed, suppose is an item or an element that is relevant to the user's intent or a goal. For example, let's talk about an utterance like book me a flight to Delhi on next week. Here, the Delhi will be the destination, and the destination is an entity. And book me a flight to Delhi on next week. The next week will be the time or the date entity. And the next is the intent. It represents a task or actions that the user want to perform. Suppose it's a goal that we so basically it's a goal that we need to achieve based on the utterance. Suppose we have an application, an online flight booking application, and we have and the user is giving input like book me a flight to Delhi on 24th. So here the CLU identifies that the utterance is the book, is the text that we have given, and the entity in that utterance will be Delhi as the destination, and 24th will be the date entity. And intent is the final output or the action that we need to implement. So the action should be book flight. So that's the action we defined or the intent of the utterance that we have given. And intent is a representation of task or action that the user wants to perform. I hope that everyone is everyone is on track with me, right? Okay. So Azure CLU process life cycle. So the CLU life cycle starts with the defining your schema. Like the first process that we need to specify, we need to categorize, we need to know our data, and to define the actions and relevant informations that needs to be recognized from the user utterances. We can create intents and entities based on this data that we are about to process. So from the data schema that we need to identify all the entities and all the intents that we need to perform. And the next is the label data. The label data is nothing but is providing sample utterances to your application, to the CLU. So in that utterances, we can specify or we can recognize the entities in that utterances. And the next model and the quality of the data labeling is one of the key factor which determines the model performance. So so suppose like what book me a flight to Delhi on next week, and I want to book a flight to Delhi on next week. So these are two types of utterances. So based on the number or based on the quality of the utterances that you are given to the system, your performance, your model performance will be improved. So now after labeling, then we need to train our model. So on the training process, the models, your model starts learning from the labeled data. And there is a tool to view the model performance in the Azure CLU to see how the model is going to perform based on the new data. After reviewing the model performance, we can, if the performance is not adequate, then we can relabel the data and again repeat the process to train and achieve the to train the model again and to achieve the model performance that we needed to be implemented. And finally, we need to deploy this model, and that will be that will be available using a kind of runtime APIs or means of REST APIs. And this consuming this deploy model or consuming this APIs, we can predict the intents and entities. And the basic use cases that we use the conversational AI are customer support automation and enhanced search capabilities, intelligent document processing, personalized marketing, voice-activated applications, multi-language supports, content moderation, training, healthcare, banking, etc. Here we will be having a small demonstration on enhanced query or the enhanced search capabilities. So what we have is in our normal applications, we can see grids which shows a large amount of data. So we need to perform search on that grid based on our conditions that we needed. In that case, what we usually does is like that. We need to figure out the way to perform the search or way to perform the filter in that. So that's the kind of traditional querying where we need the structure queries, and we need to know exactly what we need to search or what we need to query and how to query that. Suppose if I want to find an employee, or maybe a kind of employee applications. And if I want to find an employee who is drawing a salary less than $1,000. So what we need to find is here, we need a kind of technical expertise, like we need to sort by means of, or we need to filter by means of the salary. And then we need to figure out all the employees who are falling under that specific category. While in case of conversational querying, we use the natural language processing without needing to adhere to a strict syntax or a structure, or maybe not needed any kind of a technical expertise. So here, like what we discussed, we will be using the Azure CLU for performing the enhanced query. So here you can see that I have created a project named as CLU demo 1. So this is a conversational language understanding project. So you can see the first step that we need to define is the schema definition. So here we can specify the intents and entities. Here what we are going to achieve is we have an application, we have a database which contains a student information. You can see that here is a structure, it is a SQL database named as CLU demo, and it contains some information about the student and their gender and the subject that they are studying and the marks they have achieved and the location where they are residing. So we are performing an enhanced querying in this one. For that, first we have identified the entities there. We have identified location mark, name, sex, and subject. So these are the entities that we have identified from that model. And you can see that location is a learned, which is an information from a list where we use the locations from the states of US. And mark is the one which is a pre-built entity where it contains integers. And name is the person name, where we can add the pre-built entity there as the person name. It specifies the name of an individual. And the gender is also a list, and the subject is also a specific list. And the intents, what we have defined the three intents here. One is create student, the other one is get student, and an update student. So create student, I have added a couple of utterances here. So for adding the utterance, you can select an entity, select an intent from here, and write an example for your utterance. So let's add a new one. Here, a new utterance has been created with an entity, with an intent of create student. And from that utterance, I can specify, sorry. I can specify that create Prakash is a name, and male is a gender or sex, and Florida is the location, and 76 is the mark. And I need to save the changes, and it will save, and it will be saved. And now what we need to do is to train we need to train that label. So for that, we can start a training job here. If we have an existing model, we can override the existing model. Otherwise, we can create a new training model here. So we can specify the training mode here, whether it is free or advanced training, whether you can use neural networks, transformer models or not. And you can specify the split data from here, and then specify whether need to train or not. So the training job has been started. It will take a minute, mostly within a minute, it will be finished. Okay, training has been completed. Now we can view the model performance here. You can select the model here, and it has been trained successfully. And you can view the scores and the precision recalls and everything here. And also it will suggest the ways to improve the model performance. So it will suggest different different methods for improving the model performance. And now then we need to deploy this model. So it has been already deployed. We have added only one more intent there, one more utterance there. So either we need to either we can deploy or we can use the existing one. So I will add a deployment here. So it is choose to override the existing one, and it should use the trained model what we have here. You can specify the region. Okay. Deployment has been completed. After upon selection of the deployment model, you will get a prediction URL. So this is the URL or the API that we need to use to access the conversational language or the model. So you can make a post request to here with the parameters, and you can test the deployment here. You can select the deployment, and you can see. Let's see. Details of error. Now run the test. So here, from the intent, from the utterance, you can see that the top intent that has been identified is the get students. It has a confidence score of 61.2%. And the entity that has been identified as the name with Arun. You will be getting a JSON value here. So what we are going to do is like suppose we have an existing application to manage the students, and we have a query processing engine there, or we already have a search engine there. So what we need to do is we need to create an engine which consumes this API and identify the intents and entities from the utterance that we have given to the CLU. So here I have created an application. It will be going through a little bit technical, so but so this is the application that we have created. So in this query tab, you can enter a query text here, and there is an execute button. So what we will do is we will receive this text that we have added as a query, and we will parse that through the CLU. We will make an API call to the CLU and find the intents and entities from that CLU API, and then pass that intents and entities to the application to perform the search. Here you can give a query like that, show all students. We'll be displaying all the students. So what it has been performed is making a call to the API that we have defined here. So this has been generated from the from the model. We'll get the prediction URL here that has been used here as a for making an API call, and we will get the entities at intent from that from the utterances that we have given in the application, and split up those intents and entities, and then based on that we have generated we have created methods to find the students or to create the students. So let's try another query. So all male students. Here you can retrieve all the male students here. Students. Students studying. Machine learning. So suppose if we need to find in case of traditional querying, so we need to iterate through the we need to have a technical expertise or a technical skill to use this grid and to make a filter condition. So even if non-technical users can also find the information what they are needing to or what they are looking to by means of using the natural querying here. Here we have created and we can create a new student here. So, 75 in machine learning lives in Georgia. So we have added the Ram Gopal here. So we don't need to submit a form or enter the details into the form and to create and to click on the submit button to add all those informations. We can just write a simple natural language text to add a new user to add a new student. So this is a simple example to demonstrate how we can utilize the new the NLP or the how we can utilize the conversational coding with the help of NLP into our applications. In our applications, most of our applications will be having having areas like full site search, global search, or kind of any customer support queries or all those things. So we can use a simple query parser along with your grids or along with your search to find the informations. Like suppose if you have a workforce management system, let's assume that we have a workforce management system, and I am one of the user coming into the application or accessing the application. I want to find out all the work orders assigned to me on that specific day. I can just simply enter, show me my today's work order. It will display all the list of work orders that has been assigned to you on today. So those kinds of processing or those kinds of querying can be performed by means of conversational AI with the help of conversational language conversational AI tool provided by the Microsoft. And if you are about to implement the framework, or about to implement a conversational language understanding in your application, you need to find out the organizational goals, or you need to find out the goals that you need to perform, like where we need to implement the CLU parser, and where we need to in which all areas that we need we need a conversational language understanding, or a kind of search querying, or kind of things that we need to implement. And then we need to choose an appropriate CLU tool or a platform. Like there are other CLU tools, there are other tools available by means of Amazon, by means of AWS and all. And then we need to train our models based on the data sets that we have, and then integrate into the existing system by means of a parser engine or a kind of integrator engine. And the most important process is the monitoring performance. We need to iterate, we need to constantly monitor the performance and iterate, or we need to implement iterations for retraining the models, for making it for improving the performance of the system. And the future of NLP is with Gen AI and large language models. So there are few tools available in the markets, which has been supported by means of LLM, that provides the capability of making the more flexible natural language querying. But these systems might require one of the major disadvantages of this system is like that it requires a high-end computational requirements, like it requires a heavy data sets or trained model, a large amount of data for training, as well as for a higher machine requirement for processing the training and all. So most of the companies now using a hybrid approach, where they use a combination of LLMs along with the traditional frameworks for generating or the parsing the queries. So they can utilize both of their strengths, or both the features for generating the outputs for the query process. Yeah, basically that's it about conversational language understanding supported by Microsoft.